So, so good afternoon, everyone. And before we start this session today, I would want to understand and know one more thing. In the survey we conducted yesterday, let us just have that survey done again. And I want to understand what has changed from today to today, yesterday to today. Okay. So we will launch that survey in a little moment, in a little while, as more people join in. But what do you remember from what we discussed yesterday? What were we doing yesterday? Who can help us revise these points, yesterday's points?
We discussed about component analysis, then introduction analysis, then the super system engineering system,
and
yeah, those things actually I remember.
So yes, we first tried to re-emphasize. I was trying to re-emphasize that why is this problem identification stage important in the first place? That we are in this stage of problem identification. Why are we spending that kind of time on it? Because if we spend sufficient amount of time on it, we will be able to arrive at some very simple problems, which can be the solution to the big complex problem that we are facing. In cause-effect chain analysis, we saw that there was a big problem, and there could be simpler, just one or two small simple solutions can actually make a dent into how the problem is perceived and handled. And solving those simpler problems is much easier, much more economical, much faster than solving the big one. So that was what we saw in cause-effect chain analysis. And we said that we want to do function analysis so that we understand the system, the engineering system better. And as we do that, we will be able to identify simpler problems that are leading to the complex symptoms for the system. And once we solve those simpler problems, we will be able to solve the big problem will automatically get solved. That is why we are entering into this function analysis part of problem identification. And today, hopefully, I will be able to take you through the phase where we talk about how quickly you could arrive at some simple solutions given a function model available, when the function model is available to you. Okay. So before we move forward, let us do a quick poll on the project part, because आज के session के बाद, in today's session, I will also ask you to do some activities, and that is where it will be important to be able to work on your projects. Okay, if you not progressed on the project, then I will give you some simple products that you could do those activities on, which is also fine. But if you do it on your project, it can probably help you for the project right away. Okay, so I have launched the survey. Can you please quickly let me know what the status is for your project progress? So let's quickly do this. Another 10 seconds, please. Okay, I'm ending the poll now. So from where I look at it, it seems that many of you met yesterday, or probably you're talking about the last class you meant that last Tuesday, even then. So many of you have met after the class and you have worked on something. And more number of people, more teams today have consolidated ideas, one idea that they would want to take forward. Many teams, a large 55% of teams are still at 2 to 3 ideas, and we are zeroing in. Okay, fine. And I see there is much more positivity today than there was yesterday, in the sense that about 70% of us are excited or curious to see how it unfolds. The remaining are still in the process of analyzing the problem. Great. So thanks for this quick, dip thing for me, dip view that you gave to me. Now we will just move to the class. Let me start with the aspect of the logistics in terms of are you able to see my screen now?
Yes, sir.
Friends, you should have spoken. I just realized that the video had gone into the music mode. The waiting screen had come. ऐसा हुआ था ना? You were not able to see my slides before
Yes,
this.
sir.
Yes,
We
yes,
thought
sir.
you had to
Yes,
go
sir.
somewhere for something. That's why we didn't say anything.
Yeah, that's what we thought.
So that was not what I was doing. I was actually speaking and I was talking about office hours. So let me spend just a minute on office hours. Okay. Yeah. So this is the office hours that we have. Okay. And my office hours were yesterday. I will also see if I can have another set of office hours on Friday. Amir will meet you today. Will meet you tomorrow. Abhinav will be available on Thursday evenings, 9 to 10 p.m. Ribha will be available on Friday nights, 10:30 to 11:30 p.m. Okay. Soumya will be available on Friday afternoons, 3:30 to 4:30 p.m. If any of these office hours do not work for you, that is, we see that the participation in the office hours is low, we will come back and we will review and we can change office hours as needed. But this is the planned schedule as of now. Is that okay with everyone? Any concerns you have?
So only I think, sir, your office hour if could be adjusted to some another day, that would be very good, because it's just after the class. So I mean, we can't discuss if it is on some other day, then we can discuss these
Yeah,
two classes
sir.
also. So Monday and Tuesday also.
So that is what my my office hours. Let me see वो क्या हो जाएगा फिर? Monday Tuesday को class है, हाँ. So Monday Tuesday को there will be no office hours then. Wednesday, Thursday, Friday में then all these office hours will be clustered. Will that be fine for you?
So you can have an office hour on the Tuesday, I think. It would be before class or after class, whatever.
No, so any TA can take it on Monday and Tuesday, and your office hour can be shifted to some other Thursday and Friday like this. That could happen that.
Okay, let me check with them. So for me, actually, other days availability was still more constrained. So I will see if, but because Friday mornings we can't keep. Am I right? Mornings you would have classes.
Yes, so mornings, not mornings.
Yeah. So for me, Monday afternoon was the one that was most available. That was where I had requested other TAs to choose some other timings, and I said I will keep it on Monday afternoon. Would keeping it at 4 p.m. on Monday help? Like a little larger gap from the class? Will that help?
So not much, I don't think so. Take the shift.
Because then what I'm hearing is that जिस भी TA के उस दिन office hours होंगे आप उसको भी नहीं utilize करेंगे. Am I right?
नो सर, मतलब ऐसा नहीं होना चाहिए वैसे.
तो फिर तो मेरे भी यहाँ तो चल जाना चाहिए.
सर एक्चुअल में मतलब उस समय क्या होगा ना, आपकी 2 क्लासेस जो हो जाएंगी ना मंडे ट्यूसडे, वो हम सीधे सीधे आपसे डिस्कस कर सकते हैं डायरेक्टली, मतलब किसी और डे पे.
Okay, let me see if I can work out office hours on another day. We will work on that. I will talk to my TA team and we will see if one of the other slots can work for me. Then I will take that. Okay, but
Okay.
it's my you know, there's so much on my plate. 2 courses, Rise event coming up. So many things are on my plate that my calendar is actually very swamped. So my calendar is actually very swamped, and therefore it's tricky. Let me see how we can work it out. Okay. So so you do not realize how my weekends are also booked already by other project meetings. Let's see. I will consider these requests. Okay. I will see if we can keep the office hours on either Friday or then on, maybe I will keep one on Saturday, one office hours on Saturday. That's it. Saturday is convenient for all of you for office hours?
Yes, sir.
Yes.
Yes,
Hmm?
sir.
So let me see if I can find some time on a Saturday to conduct the office hours. Okay. Yeah. So now coming to the function analysis, yesterday we saw that there are three stages of function analysis. First stage is component analysis. Then we do interaction analysis. And then finally we do the function modeling. In component analysis, what did we do? In component analysis, we identified the components of the engineering system and its super system. So what is the difference between engineering system and super system?
Super system includes all the other things in the environment that interact with the engineering system.
And engineering system is?
Just the machine part in the super system, like.
Engineering system is the system on which you are working. When you call it a machine, you make it sound very mechanical, Soumyadeep. There was already a concern कि ये चीज algorithms पे और computers के लिए, software के लिए valid है कि नहीं है. So don't call this word a machine. Engineering system is already a very loaded term. Okay? So yes, engineering system is the system that which we are working on, and super system is the context in which it operates. So all the things that my engineering system interacts with, is touching, is dealing with, would become a part of super system. For example, if it's a computer program, then the user who gives the inputs, the user who receives the output, the printer and other stuff could be super system components. Whereas the program itself, the algorithm of the program itself could be your engineering system. Interaction analysis, we looked at the interaction analysis then, and we also looked at a tool called interaction matrix to list down that interaction analysis. Where what we said was, wherever there is a touch happening between two different components, only in those places there is possibility of a function. So we said that we will put a plus sign in all those boxes where there is a interaction happening, a touch happening, and put a minus sign elsewhere. Then we came to the stage of function modeling. In function modeling, we said that it identifies and evaluates functions performed by the components. So functions performed by components, we looked at some aspects of it. We said that there are a few mandatory conditions for function to exist. The first condition is that both the function carrier and the object of the function are components of the system. Now, these components could be either substances or fields. What is the difference between substances and fields? What was it that we discussed yesterday?
Have rest mass and do not have rest mass.
Yes, the substances have a rest mass. Fields do not have a rest mass. Fields could be fields like magnetic, electrical, acoustic, mechanical, fields like gravity, and so on. And substances are objects with the rest mass. Then we said that the second thing is, the second requirement, mandatory requirement for a function to exist is that the function carrier must interact with the object of the function. There has to be some touch happening. And then the third thing we said was that some parameter of the object should change or possibly simply maintained. Maintained is also a change, because if that function was not happening, then due to entropy, something would change. So we are acting against entropy. So even maintenance of some parameter could be the result of that interaction that is happening between the function carrier and the object of the function. And then we looked at some examples of what kind of functions there are. So we also looked at that there is no function that an open door is doing. Why? Why is there no function that an open door is doing?
So because it is an object and there is no interaction between that a girl entering the door and the open door.
Yes, because an open door does not interact, it does not touch the object of the function. If you say that you would let a person pass, the open door doesn't touch the person. So there is no function that an open door has. We also said that we will not use any negative formulations. We said that we will not use declarative formulations. What were the kind of declarative formulations we looked at yesterday?
So cleaning, like tooth cleaning, basically.
It cleans. The brush cleans the teeth.
Protection from helmet.
We will not use the terms like clean, protect, safety, all these things, which as engineers you cannot really do much about. As an engineer, you need to understand what needs to be done, what parameter needs to be changed. So we need to be as specific as is possible for us. And if we can't really think of a good verb, let us simply use the thing like, the function carrier changes y parameter of the object of the function. So function carrier hammer changes the position of the nail. So instead of, like, if we do not want to use the word hammer moves the nail, we can say hammer changes the position of the nail. And then we also discussed that we will document only consequential functions. We will not document inconsequential functions. And which functions are consequential can depend on which system, which context they are operating in. We took the example of coffee. We said that typically air cools coffee is a function of consequence, and that coffee heats air is not a function of consequence. However, if you were the one who was designing the air conditioning of that barista cafe or the cafe coffee day, then how many customers are there and how many hot coffees are being sold is a parameter of interest to you, because that coffee would be heating the air, and that air, the primary function of your engineering system is to cool the air. So this, in this context, coffee heats air also becomes a consequential function. In fact, air cools coffee is inconsequential in that context. Are you able to see this?
Yes.
So now we move a little further. What we are now saying is, in this diagram, is that any component of a system can be both a function carrier and also object of functions. So it could be function carrier, for example, for function 1 and function 2, but it is an object of function for function 4. This particular component is object of function in function 3, but is a function carrier for function 4. What we are also saying is that any component could be performing more than one function in any engineering system. Is it okay? Let's look at an example. What do you think is the main function of this car? So there is one main function of any engineering system. So what is the main function of this car?
Traveling.
Transportation, traveling.
Solving
Let
the
us use the
traveling.
language of functions. Let us use the language of functions.
So to move from one place to another.
To move itself.
People.
Yes.
Transport people.
So the main function of the car is to move passengers and cargo. The car moves passengers and cargo. You can also load luggage into it and it would move luggage also, nahi? So whenever we start to do function modeling, the first thing to do is identify what is the main function of the car, of the engineering system. Now, the object of the main function is typically a part of the super system. And it is called as target. So in context of the car, the main function is moving passengers and cargo. So passengers and cargo, do you realize both are targets? Both are outside the system. Both are not a part of the car. And both of them will be called as targets. They are super system components and they will be called as targets. Okay. Now there could be other super system components also, which could be there. For example, road. The car moves on the road. So the wheels of the car, for example, would rub against the road and therefore the car would move forward. Am I right?
Yes.
So road is a super system component, and there are some components in the engineering system which are interacting with the road. So there is some function from the system to the super system, but clearly there is some function from the system to the target. And this function is called the main function. When we do any modifications in our engineering system, we cannot remove the target, because that was the main reason why the engineering system existed in the first place. Are you able to see this? We will look at a few examples and this will become more clear. But let's just understand that this is pretty evident that if an engineering system exists for a particular purpose, that purpose is the main function of the engineering system, then the target of that main function cannot really be removed from existence. It will be there. And whatever else we do with the engineering system to improvise it, the target should get its main function still resolved. Whether component 18 does that main function, or I reassign and repurpose component 1 so that component 1 does that function, that is a different thing. But the main function cannot be deleted from a system. because that is the primary reason why the system existed. Now, what we are saying is that once we have identified the target, we should know what parameters of the target are also changing as a result of the main function. First, main function cannot be removed. Then we should understand what is the desired change in parameters, and then we should try to enhance it. For whatever projects you are choosing to work on, once you know the target, you know what the main parameter is, and then you can work to improve the performance of that function. Okay. Now, functions can be categorized into two kinds: useful functions and harmful functions. Useful functions changes the parameters of the object of the function in a desired direction. For example, in yesterday's office hours, we were discussing the problem of that due to this online e-commerce, local shops are suffering. So we were thinking of a solution where the local shops would get more footfall or would get more orders, and they will be able to recover their loss of income. So that would be the useful function. Now, there could be other parameters, or there could be other components in the super system or in the system which could lead to worsening the parameters of the object of the function. Those functions are called harmful functions. For example, we could say that Blinkit, for example, has some harmful function for the local vendors here. Or Swiggy would have some harmful function, Swiggy Instamart would have some harmful function for the local vendors there. But the solution that we are providing is providing useful functions. It is taking care of, it is removing the harmful functions that Blinkit has. It is removing the harmful function that Swiggy Instamart has. So it is important to understand what are the harmful functions in an engineering system also, so that overall efficiency of the system can be enhanced. So functions are categorized as useful functions and harmful functions. In the case of a toothbrush, useful functions could be like bristles distribute toothpaste, bristles remove food, bristles remove plaque, and harmful function could be bristles damage gums. So if we can have a toothbrush which would do just these two things and not this, it would be a better toothbrush. Is it not? Hello?
Yes, sir.
Yes, sir.
Yeah. So it is important to categorize functions as useful functions and harmful functions. Now, useful functions are also further categorized into a zone where we talk about how effective those functions are. So you wanted a system to do a component to do some useful function. It could happen that it is doing that useful functions a bit too much, excessive, or it is not able to do the function at the required level of performance. So it is insufficient, and then it could be normal. So excessive and insufficient levels of performance are disadvantages in the engineering system. Now, if you come to think of it, excessive performance of a function sounds to be good. When do you think it is not good?
When the thing becomes uncontrollable.
Okay. Yes. Can you give an example, Devjit?
Let's say a circuit level example only. So let's say we are having a big NMOS which is leaking. So if we are not able to control that leakage at FF125, it would leak at a very high rate.
So Devjit, leakage is a harmful function. We are not categorizing harmful functions at all.
So for example, a braking system can stop the car very quickly, like instantly. So that can hamper the driver.
Very good. Yes. A braking function stops the car instantly, so you can actually, a passenger can actually hit the dashboard. Or the car was moving, and the movement it performed excessively. So it was supposed to stop somewhere. It moved excessively, did not stop there. Or you were rubbing a surface to clean it. You performed the function excessively such that the paint also got removed. So excessive functions, excessive performance of a function is also not good. It could lead to situations which you do not want to happen. Then you have to correct it. आपको वापस पेंट करना पड़ेगा, आपको वापस पॉलिश करना पड़ेगा. So excessive performance of a function is not desired. Insufficient performance of a function is definitely not desired. I think that is intuitive enough. We always want normal. At times, excessive performance of a function may not lead to any immediate harm. In fact, could be desirable, but it is not something which is leading to any profit, additional profit also. So you would say, let me save costs, because in performing this function in an excessive manner, I am incurring some extra cost. So let me save cost. So again, it is undesirable. Okay. So once you have labeled functions as excessive or normal or insufficient, another ranking or a ranking of the functions is also desired. A function which is directed on the target is a basic function, and it is assigned the highest rank 3. Let us say 3 points. Function directed at any other supersystem component is an additional function. Again, engineering system का main function नहीं होगा वो शायद, but it is still an important function because it is acting on the supersystem. It is called as an additional function. It is assigned 2 points. A function directed at a component of the engineering system itself is an auxiliary function and assigned only 1 point. Do you remember we made a chart of value where we said that sigma of functions upon sigma of costs, and we said that more functions and lower cost is high value? You remember this? We wanted to be in this quadrant.
Yes, sir.
Yes,
So
sir.
this ranking, this giving some points to different functions is being done so that we can place different components in these quadrants. So if a particular component is involved in a basic function and 2 additional functions, we would say the sigma of function is 7. If it is involved in just one auxiliary function, then the sigma of function is 1. So it would lie somewhere here. Now, depending on the cost, it could be in this quadrant or in this quadrant. This one would probably lie somewhere here. Depending on the cost, it could be in this quadrant or in this quadrant. But this ranking is being done so that we can assign some value to the function, to the components of the engineering system. How we will use it, we will see later, but it is to place components on this matrix. What is the value that any particular component of my engineering system is bringing on the table? So any questions till now, or we look at an example and then wait for questions? Anything that is not clear yet? Okay, so let's look at an example, and probably if there is anything which is not fully clear yet, you will be able to see what you will be able to get more clarity there. Let's look at a toothbrush. A toothbrush has parts. So what all could be a part of the engineering system over here? How would you define the engineering system over here? Which components are a part of the engineering system and which components are a part of super system? Quickly.
So all the parts that are associated with the brush, because the handle, the rubbing part, and where the base part, where the that is the engineering system.
So we are saying this is the engineering system.
Yes.
And the remaining is super system.
Yes.
Okay. Anyone else and any other ideas around this? Okay. So we now know what is the engineering system, what are the super system components. So now we start to plot the functions there. Hand moves handle. Hand holds handle. Handle holds the head and moves the head. Head holds and moves the bristles. Bristles distribute paste. Bristles remove plaque. Toothpaste removes plaque. The handle informs the person that the tooth, like what is the progress in terms of brushing the teeth. So all these functions are happening in this engineering system. Should we start to rank them now? So let us say, what rank would you give to the function that handle is performing on the head? What is the total function addition that the handle has? Quickly, what are the functions that the handle does?
The informs can be a additional function.
Okay, so what is the target for you?
The teeth.
Okay, target are not teeth. Target are plaque.
Oh,
Removal of plaques. Yes.
You do not do it. It does not do anything to the teeth, huh?
yes.
The target is plaque and other food or whatever. And then the person itself is another super system component, and you are informing. So okay, you say informs is the additional function. What about holds and moves?
That can be the basic function.
Hold and move are basic functions. What is a basic
It's
function?
auxiliary.
Basic function is something that is happening on the target.
Yeah.
So holds and moves are happening on the another component of the engineering system only. So they are auxiliary functions. So we're just labeling that. Informs is the additional function. Basic functions are only this. And basic functions are done by the toothpaste and by the bristles. All other functions are either additional or auxiliary. So if I want to now assign a function contribution to each of these components, what would that be? The handle has a functional contribution of 4, the head has a functional contribution of 2, and the bristles have a functional contribution of 5. Are you able to see this? So if you now want to remove something, what would you remove from the system? What could you remove?
The base.
We don't know that yet. No. We don't know that yet. Because what have we done? In our matrix, we just found where the different parts lie. We say, okay, the bristles lie somewhere here, anywhere on this row. Handle lies anywhere on this row. And the head lies anywhere on this row. We do not yet know if what is the cost involved there. So we can't say what to remove yet. We need to know what is the cost involved. And then we can remove something. We can decide to remove something. As of now, we are not in the position. Are you able to see this? Hello?
Yes.
So now what we are saying is we have kind of identified the steps for creating a function model. We say indicate a component, identify and indicate all the functions of the chosen component using the interaction matrix. Then determine and indicate the function ranks. Next step is determine and indicate the performance level of the function. For example, we could be saying that the performance of this removing function is excessive. Not only does the bristle remove plaque, it also removes the skin of the gums. So something needs to be done with the bristles. Or we could say that there is another component, gums and bristles also are interacting with them. This is an additional function and this is harmful. That it harms the gums. Are you able to see this? So we pick up a component, we see wherever there are the interactions, what are the functions involved there? And we do this for all the components then. So how to identify a function from an interaction matrix? First thing is the cell should contain a plus sign. Now, when there is a plus sign cell, realize there could be one function, there could be many functions, and there could be no functions at all. No functions mean they are touching, but there is no function of consequence to you. So you do not add that function into your function model. A cell which has a negative sign there will not contain any function. This we are clear of. We just discussed the necessary condition for a function to happen is that there should be a plus sign in the interaction matrix. Otherwise, the function cannot be there. So then we label, we'll use the legend as B for basic, AX for auxiliary, AD for additional, harmful, insufficient, excessive, and normal. Okay. So we create this legend, and then all we need to do is we form a table. We make a table of what are the functions that exist. So let us look at the paint example of yesterday. So yesterday, Jaskirat was asking what happened to the paint example, what happened there. So now we look at that. So in this particular thing, what is the target? What is the target of this system, paint filling system?
So the coloring of that object, basically.
That component.
The rods,
that is painting of that object.
Paint filling system. नाम में ही target है. Paint is the target, bhai. The main purpose of the paint filling system is that, what is the paint filling system? This is the paint filling system, na?
Yes, sir.
So ये system क्यों exist करता है? So that I could move paint from the barrel into this, na? Into this tank. Are you able to see this?
Yes, sir.
So what is the target here? Paint. What would be the basic function? In all this, which component would be performing the basic function?
Motor.
Tank.
Pump. Pump moves paint from the barrel to the tank. है ना? मोटर तो पंप पे एक्ट करती है ना? So okay, let's go into details of this. We first make the interaction matrix जो हमने कल बनाई थी. You remember we had made the interaction matrix? So this is the interaction matrix. Now we pick up each component and see what are the functions defined there. So let's look at float. Float moves lever and it holds paint. You see, it is touching lever and paint and air. There are functions between lever and paint. The fact that air is in contact with the float is not of much significance for us. Air is just there. So udhar koi function bana hi nahi. Then we look at lever. Lever holds float and it controls the switch. Now what we are saying is, because what was happening? The paint was overflowing. The paint was overflowing. Why did it overflow? Because the lever, the float did not move the lever sufficiently. So what did we say? That this function is performed insufficiently. Now, lever holds the float properly, that is acting normally, but lever is not controlling the switch sufficiently. Because if the lever was controlling the switch sufficiently, the switch would have turned off the motor, and then extra paint would not have been pumped in there. So the action on switch is insufficient. Now the switch controls the motor. For the motor, it is the switch that is not controlling it properly. So this action is insufficient. Now, when it comes to the pump, for the pump, motor is rotating the pump for extra time. It is happening excessive. That is where it is harmful also. Due to this, pump moves the paint excessively. And you notice we have put basic over here because paint is the target. Barrel contains the paint. It is containing it normally, no problem there. The paint is in touch with the float. You see, float was in touch with the paint, so float held the paint. The paint is in touch with the float, and as the level of the paint rises, it moves the float. But it is moving it insufficiently, because had it moved it sufficiently, the switch would have been turned off. Now, tank holds the paint or contains the paint. Again, it's a basic function. Again, it's a basic function, but it is being performed insufficiently, because of which there is a spillover happening. Now, air solidifies paint, and it is a harmful function. We're not even talking of whether it is sufficient, insufficient, or excessive. It is a harmful function. No further labeling needed. This function has to be removed. Is this clear till here? Any questions?
Yes, sir, clear.
Perfect. So now what we do is, now we will make a function diagram in a different way. Now we go to pen and paper. See, till now we were looking at the shaft floor view. In the shaft floor view, you were getting confused that the parts are the target of the paint filling system. Now, if you look at the entire shaft floor, for the shaft floor, that is the target. Yes. But for my paint filling system, the system where the problem is existing, for that the target is paint. So this kind of a confusion was happening. Now we do not want any further confusion like this. So we move out from this zone and we go into a function model, which is graphical in nature. And over here, you will notice all the insufficient functions we have represented with a dashed line. There is also an arrow that we have put here, which says that over here, for example, lever is the function carrier and switch is the function object for this controls. For this particular function, switch is the function carrier, motor is the object of the function. We've actually colored the target in a different color itself. The super system components are shown in a different color and system components are shown in a different color. Because of this color coding, right away I get to know what is happening, which functions are additional, which functions are auxiliary, which functions are basic. Can you tell which functions are basic by looking at this diagram? Which are the basic functions over here? Which are the basic functions over here?
Holds, contains.
See, we've represented hold as a harmful function over here.
Yeah, sorry, continue.
So it cannot be a basic. It is not being categorized as basic or anything. It is a harmful function, has to be removed. Air solidifies paint, again, has to be removed. However, barrel contains paint is clearly a basic function. Tank contains paint is clearly a basic function. Pump moves paint is a basic function. Now it is performing this basic function excessively or insufficiently. That is why I put it in a dashed line. Okay. Is this okay? Any questions here?
Sir, why are we using normal lines and dashed lines? Can you repeat it again?
The dashed lines are to represent that something is insufficient or excessive here. In fact, I prefer to use for something that is happening excessively, I actually prefer to use a solid, very dark solid line. In this particular diagram, I have accidentally used a dashed line. Dashed lines are typically used when I want to show insufficient functions. Okay, dark solid lines, excessive function. Okay. Is that fine?
And in normal lines, they are doing the normal function.
Yeah, they're doing normal functions. Red colored lines are doing harmful functions. Okay.
Yes, sir.
Red colored lines are doing harmful functions. Blue colored lines are doing functions normally. And dashed blue lines are desired functions, useful functions, but either happening insufficiently. I would say happening insufficiently. And I would say you guys should use bold, thick lines to represent functions which are being done excessively. So visually, we are able to differentiate between all kinds of functions. Are you able to see this? I do not need this table now. It is so difficult to understand the function model from the table, is it not? Whereas as soon as I do this, it is so simple to understand. Are you with me?
Yes, sir.
Sir, one question here.
Yeah.
So, sir, have we made an assumption that the problem is at the float level? So, float is moving the lever insufficiently. It could be possible that the problem is at the switch or any other level. So, have we made this assumption?
Yeah. So यहाँ पे हमने assumption नहीं बनाया. यहाँ पे system का symptom था ये. यही तो बात हो रही थी. When we defined the problem, we said the float becomes heavy. Therefore, it does not rise sufficiently, and therefore the system is failing. So every 1 month we have to change the float, or we have to stop the system, and we have to clean the float, remove the paint from the float. When we described the problem, that is how we described it, na?
Right, sir.
So it's not an assumption. This is the problem statement. This is defined, already defined for us. Cause effect chain analysis has already been done. It is the float which is the cause, that we have understood. Is it okay?
Yes, sir. Understood. Thank you.
So that is why we did cause effect chain analysis before function modeling, so that you know where the cause is and then you model around it. Okay. So a quick review of what we are talking about. We are saying that main goals of the function analysis are to provide a functional representation of an engineering system, so that we don't get bogged down by other details and we can focus on the problem at hand. Okay. To identify functional disadvantages of the components of an engineering system, and to rank the functions for further trimming, for further action. Okay, this is such a costly component, but it is not performing sufficient amount of functions. So let us trim it and let us give the function that it is doing to something else. So the outcome of function analysis is a model like that, which could be in a tabular form, but preferably in a graphical form. And a list of functional disadvantages. So some key terms: function is an action performed by one component to change or maintain a parameter of another component, which is called the object of the function. Function carrier is the component performing the function, Object is the function whose is the component whose parameter is being changed as a result of performing of the function. Parameter is a comparable value of an attribute. Main function is the function for which an engineering system is assigned, is existing. Why the engineering system was put in place in the first place is the main function of the engineering system. Basic functions are useful functions directed towards the target. So main function is also a basic function. Additional functions are useful functions that act on components of the super system that are not the target. Auxiliary functions act on other components of the engineering system itself. Okay, and then we assigned a rank to every function. Basic functions were assigned a rank of 3. Additional functions were given a value of or weight of 2. Auxiliary functions were given a weight of 1. Harmful functions are those that worsen the parameters of its object, move them in an undesired direction. Useful functions are functions that change the parameter of the object in the required direction. And what we are saying is that a function model is characterized or is of a system describes all the functions performed by various components of the system and its supersystem, where we categorize them as useful and harmful on the quality of performance and almost cost and also cost. हमने अभी cost की बात नहीं करी अभी तक, but even in terms of cost level, where we say the cost is insignificant, acceptable, or unacceptable. ठीक है? And the value of any component is sigma of functionality upon sigma of cost. If actual value of a parameter is greater than the required value of the change in parameter, we say the function is excessive. If it is less, we say function is being performed insufficiently. And if it is at a desired level, we say the function is performed normally. यहाँ तक clear है? Any questions? Because then I would want to move to the next step, which is called trimming. I want to cover at least some part of trimming today so that you can actually go back home, start to work on the function models of your system and see if trimming is possible there or not. Any questions still here? Okay, great. So now let us look at trimming. Now, trimming is an analytical tool for removing certain components and redistributing their useful functions among remaining system or supersystem components. See, if there is a component in a system, it must be performing some functions. Some of those functions could be useful functions. So when you trim them, when you remove those components, those functions need to be reassigned to some other component in the engineering system. है ना? So trimming is not only about removing certain components, but then equally importantly, redistributing their useful functions among other components. If I am unable to redistribute the useful functions among other components, I cannot trim that particular component, even if its value that it is adding is very low. If it is the only component that can do that particular function, then I have to keep that component in my system. I cannot trim it. So let us take the example of a motorcycle. We discussed that when we were discussing TRIZ. याद है आपको? In that session on TRIZ, we discussed this example of a motorcycle. What did we want to do? We wanted to reduce its cost. So we made the function model of the motorcycle. We broadly said there are a few components of the engineering system: motor, wheels, frame, gas tank. There are supersystem components, which are road and gas, and there is a driver. Driver is the target because the driver is being moved. The motorcycle, all of this moves the target only. So driver is the target. And now we looked at, see, which thing can I trim? Can I trim the motor? If I trim the motor, is there anything else in the system that can rotate the wheels? Can the frame rotate the wheels? No. Can the gas tank rotate the wheels? No. So no way, I cannot trim the motor. Looking at the wheels, can I trim the wheels? If I remove the wheels, what will work on the road? So something, the road needs to be in contact with something which should move. So nothing else in the system, neither the frame nor the gas tank nor the motor, I would want to be in touch with the road. So the wheels also cannot be removed. Now, if I say I trim the frame, then what will hold the wheels? What will hold the gas tank? What will hold the driver? Really, itni sari cheezon ko hold karna hai, the frame is needed. Then we look at the gas tank. Can I remove the gas tank? See, gas tank is performing only one function, which is holding the gas. Do you think some other component in the engineering system can do that function? Can some other component in the engineering system do that function? Holding the gas? I can probably reassign that function to the frame. And then I can trim the gas tank. So now frame holds the gas tank, like in this particular photo. And I have trimmed the gas tank and I have reduced the cost of my system. And you have a Luna kind of a thing there. You could have other bikes which are like that. Now, it may not appear to be very fashion savvy, is it not? It looks very small. It does not give that grandiose feeling that you would want to have with the motorcycle that you own. But the cost of the system has reduced. If I would say that nahi, gas tank ko bhi nahi trim kar sakte the, to hum kya kehte? There is another person which is outsider, a roadside looker, and the gas tank informs that particular person about my social status, that I am a rich guy, I'm carrying this big a motorcycle. If I would add that function there, then that function could have been moved to something else. But since that function is not defined in this function model at all, we did not do anything about it. So the end product does not look that appealing to the eye. But that's fine. That was not even the target there then. Am I right? So let me ask you this question. What is the main function of a Ferrari car? What is the main function of a Ferrari car? If I or you purchase a Ferrari car, what do you think would be the main function of it?
So carrying the passenger simply. Any car would simply carry a passenger.
But so any car would do, na?
Yes, sir.
Speed. मैं Ferrari car लूंगा भी क्या दिल्ली में मैं क्या किस स्पीड पे चला सकता हूँ? Is speed the main function? Sorry?
Looks also, how the car looks.
Yes, it informs my society that I am a person who is rich. I own a Ferrari. Show off. है ना? So when you want to work on a Ferrari and reduce its cost, can you compromise with the looks of the car? No. Because that is the main function. You only want to further enhance it. Any cost cutting you do elsewhere. You see? But when I'm talking about a bike, there are so many people who are not bothered about the looks. They would rather have a cheaper bike. So they would go with this. Yes, there was a question. Sorry.
Yes, sir. Sir, I had one question. Sir, does the main function of an object or a system change with respect to different people? For example, if there's a racer, for him, Ferrari might not be about looks, but about performance.
Yes. Yes, it changes. Very good observation. Very good observation, Karanjot. So हम कभी भी function model जब बनाते हैं, we just discussed now that we will not show some functions in one function model and we would show those in another function model. We discussed that air cools coffee, coffee cools air. कौन सा function हम बना रहे हैं वही कौन सा इंजीनियरिंग सिस्टम की बात हो रही है उस पर डिपेंड करेगा, व्हाट प्रॉब्लम वी आर ट्राइंग टू सॉल्व उस पर डिपेंड करेगा, है ना. सो यू आर एब्सोल्युटली राइट, it changes with the context. The function model will change with the context because the relevant and irrelevant functions will change.
Yes, sir.
And,
So,
and for
yes.
a product, can we say the context is basically the stakeholder?
The context is the customer. You may say that stakeholder. हाँ, stakeholder भी कह सकते हो, vendor भी हो सकता है. But primarily for businesses, it will be customers. Customer is God, huh?
Yes.
So let us look at a few guidelines for trimming. See, select components based on project goals and constraints. अगर मेरा project goal होता कि I have to impress my social circle also, then I would have put that also as a component of my super system and a function associated with it. वो नहीं था तो मैंने नहीं डाला था अभी बाइक के साथ, है ना. And then we trim the components with key disadvantages in order to maximize the improvements of the engineering system. And we cannot trim if there are no acceptable alternatives. Okay, we will just look at some rules of trimming, and in the next class we'll also look at radical trimming. Okay, we can't cover radical trimming today, it will take a little longer, but we will look at some rules of the trimming, basic trimming, so that you can just experiment with the projects that you're working on. And radical trimming, if you perform radical trimming, you will see that the solutions could be very, very neat. But again, it is possible only if the project goals and constraints allow that to happen. Okay. Again, trimming can be less or more conservative depending on the number and relative importance of the trimmed component. So if there are 100 components in a system and the system is overall performing only few functions, you can probably think of removing many of those 100 components. But if a system has only 2 components and both are performing some function on the target, you may probably not be able to trim either of the 2 components. Are you able to see this? When there are many components, there is a possibility to trim something. When there are very few components, the possibility to trim also reduces. So let us quickly look at the rules of trimming. And you know, trimming के साथ जो key philosophy है, that less is more. That is the basic idea. So looking at the rules of the trimming, a function can be trimmed if we remove the object of the useful function. So if I've already trimmed the object of a useful function, then I can also trim this particular component. Okay. So there was a function carrier which was acting on some object. If there is no object that a carrier is acting on, that a component is acting on, that particular component can be removed. Second is, let us say the object was not removed, but I enhanced the object of the function that it could now do the useful action by itself. For example, self-service wala principle, where I say that something self-serves itself. So if that self-serving is already possible, then I do not need to have another function carrier. I can trim the function carrier now. Another way to remove an object is assign the function that was happening to another function carrier in the engineering system, and that new function carrier or that other function carrier now performs the function. A function carrier can be trimmed if another component becomes the function carrier instead. Okay. So 3 rules. Function carrier can be trimmed if we remove the object of the function. It can be trimmed if the object of the function does self-service. It can be trimmed if some other component can be assigned that function. Now, to select another component as a new function carrier, at least one of the 4 conditions should be satisfied. First is that the component may already perform an identical or similar function on the object of the function. The component already performs an identical or similar function on another object in the system. A component performs any function on the object of the function, or at a minimum at least interacts with the object of a function. We will see what this means. This might look cryptic. आप इसको दोबारा से पढ़ेंगे, it will become simple for you. Or the component possesses a set of resources necessary to perform the required function. Let us look at the example of toothbrush. Toothbrush में 3 components हैं: the handle, the head, and the bristles. Let us say I want to remove the head. Head had the minimum functionality there. I remove the head. What happens? Is there anything else that is performing some function on the bristles? No. There are only 3 components. Handle does not interact with the bristles. So there is nothing it can do. Now, handle, however, performs an identical function, which is hold and move on the head. You remember? Handle held and moved the head. When you cut off the head was actually holding and moving the bristles only. So hold and move, both functions are being performed by the handle. I can probably transfer this particular function of holding and moving the bristles also to the handle itself, and not have the head there. Or in some cases, there may be a component that is performing any function on the object of the function. So some interaction it is happening with the bristles. And then we could say that, okay, that is good enough. We will assign it the function. Or the component may possess the set of resources necessary to perform the required function. So you go from the first rule, second, third, जहाँ पे आपको एक अलग component मिल गया, you don't need to go further. Okay, so this is the sequence in which you will approach identifying the other component for acting as a function carrier. So the function model of the engineering system as it would exist in the future after the trimming is done is called as the trimming model. And therefore, there will be many trimming models because you could trim many different components. In the case of a brush, we could trim the handle also. We could trim the head. We could think of trimming the bristles also, because bristles are performing the harmful function of bruising the gums there. So from one function model, you could arrive at multiple trimming models. Each trimming model will give you a different problem to solve. Okay. So how to do the trimming? Select an engineering system component to be trimmed. We selected the head of the toothbrush just now. Then select the first useful function of the component to be trimmed. The head was doing 2 functions, hold and move the bristles. So we picked up the function hold. We applied the rule and we found that we have to move or reassign the function to another carrier, and we reassigned it to the handle. So the handle would move the bristles. Then we picked up this, we formulate the trimming problem as how can the handle move the bristles? Now we pick up the next function. The next function was hold the bristles. So we said, okay, let the handle also hold the bristles. So the problem becomes, how can the handle hold the bristles? And you repeat steps 1 through 6 for all the components. We did this for the head. Now we can do the same thing for the handle. We could do the same thing for the bristles also. And then we would have multiple alternate trimming models. Let us look at the paint filling system example. In the paint filling system, we had this function model. Now we see that there is a harmful function that the float is performing on the target. Let us say we want to trim the float. If I trim the float, what do I need to do? If I trim the float, all the functions that the float was doing, all the useful functions that the float was doing need to be reassigned to something else. So automatically, since the float is gone, the harmful function is already taken care of. No need to worry about anything. Now, the float was doing one useful function, which was moving the lever. Now my problem is how to move the lever so that the system can still function well. Can you think of ways in which paint can directly move the lever? Because paint was moving the function, the lever, the float earlier. Now, since the float is gone, can we think of ways in which paint can move the lever directly without the float? Can you think of some ways?
So you can use the property of the weight of the paint. As the weight increases, something can be done. Likewise, the tank could be associated with the lever.
Very good. Very good. So what we could do is we could say that okay. So okay, the lever could be moved by weight, but वो थोड़ा सा tricky है. हम lever को भी trim करते हैं, then we will move the switch by the weight. ठीक है? If we move, so what we do is we say that the tank, for example, moves the switch. How? We, instead of this system, the problem is how to make the tank control the switch, because the float and the lever are not there now. The solution could be put the switch below the tank. There are springs. As the weight increases, the tank would lower itself and the switch would be closed. Now the pump would not do anything. So very good. Can we do something else?
So one more thing, I mean, an electrical solution is possible if paint is acting as a conductor. Then we can simply use an electrical property to just close the circuit whenever paint reaches the top. So if it just circuit closes, then simply the switch will go.
Very interesting. But see, that thing would also have the same problem, that paint would solidify on the contact also.
Yes, sir. That's solidification problem also.
So we will enter into the same problem again. We need something different, easier, simpler. Can you think of something simpler?
So we can maybe have a timer that depending on the paint just starts the motor and closes the motor.
See, they do not want to go in with sensors and timers there because they are costly components. You know? Springs are simple, very easily available, very cheap. But timers are electronics now. You have to add many more things in the system. You want to remove stuff. In trimming, you want to remove as much stuff. You do not want to add stuff. Okay, let me give you another example. If the function of control the switch could be performed by air. Abhi tak we said that the function of controlling the switch was performed by the tank. Can you give the function of controlling the switch to the air?
Yes, sir. But then the chamber must be closed, and a panel would be there on the top of the paint, so that paint, whenever moves up, it moves that chamber also, and so as the air vents out, and then that switch could close. Yes, sir.
Very good, very good. So we have trimmed this. Now we say that the air controls it like this. As the paint moves up, the air in this tube compresses. It pushes the switch down. हाँ, good. So आप लोगों को तो सब आता है. आप लोग तो solutions निकाल सकते हैं अपनी problem के लिए. So see, now we have already moved into. We are already talking of some solution finding. That is not the intent. For trimming, the intent of trimming is define a new problem. What was the initial problem? The initial problem was the paint is spilling on the floor and I do not want that to happen. That problem has now changed to how to make the air control the switch. है ना? So, and controlling the switch we could simply do by using this kind of a thing.
Also, so here we solved one more problem, that air was solidifying the plate. So that was also solved. That was ample solution.
Yeah. So now I could have an inert air in between which would not interact with the paint at all, would not solidify. है ना? Or it could be an air which would not let which would have some, say, vapors in it which would not let the paint solidify there. That could be done so this pipe remains clean throughout. So what we really need to do is we need to define what is called as trimming problems. How to make the component 2 perform function 1. How to make the component 3 perform function 2 by itself. So at the end of this trimming exercise, you will have a long list of trimming problems which would be simpler than the initial problem that was being provided to you. And as you solve, so they may be simpler, they may be more complex, we don't know. But instead of that one big problem which might have been intractable, now you have multiple problems on which you could work. And you can choose to work on the simplest one, the cheapest one, the most effective one. So that is why trimming is also a part of the problem identification stage. It is not a part of solution finding stage. चाहे हम अभी solutions को भी दिखा दिया मैंने आपको, but trimming is only about defining the new problems. We will use ideation methods to find solutions later, but abhi we are simply defining new problems. Okay. So friends, how many of you are willing to stay for another 5 minutes, and only 5 minutes? I want to show you magic happening. The same float and body problem, I want to show you how it can be done like this by radical trimming. We are in the flow. Are you willing to stay for another 5 minutes?
Yes, sir.
Yes, sir.
Okay. So radical trimming. We were here that we have removed the float and we have removed the lever. Now we say, I want to go radically, I want to trim as much as possible. So I don't want to go to air to control the switch. I don't want the tank to control the switch. All these components are only performing one auxiliary function. You notice? Switch is performing only one auxiliary function. Motor is performing only one auxiliary function. Pump is performing only one auxiliary function. So so these are very low functionality components. There is cost associated with each of them. If I can remove all of them, then my system cost would reduce significantly and the overall functionality would still be achieved. So I would be arriving at an ideal solution. And we are able to say this because we are seeing that these components, remaining components in the engineering system, are also performing only very simple auxiliary functions. None of them is performing an additional function. None of them is performing a basic function either. So we can really think of trimming these components also. So let's go ahead and trim the switch. If the switch does not exist, then something needs to control the motor. Now let us remove the motor also. If the motor does not exist, then something needs to rotate the pump. But you see, pump is performing a basic function. It is working on the paint. If I want to trim the pump, some other thing over here, either the barrel or the air or the tank, has to move the paint because the basic function I cannot remove. Are you able to see this? So either something should rotate the pump or something should move the paint. I say pump, let me remove, because let me remove that cost. So something now needs to move the paint. Now there are only air, tank, barrel, and paint. We have already seen that air can be used to move the switch, to control the switch. Do you think you can use the air to control the paint also? Now the trimming problem is, who moves the paint? Can the paint move itself? Any ideas? अब मैं जब आपको सॉल्यूशन बताऊंगा ना, you will say, अरे ये तो हम रोज देखते हैं.
Sir, sir, the tank can be placed at a higher potential, so the potential energy would means paint can easily pour itself down.
Yeah, but हमारे को control करना है. We have to also stop the paint from moving when the tank is full.
So we can put a horizontal pipe from the barrel to the tank, and the height would be the same. कि barrel में जितना height होगा उतना ही same height will be maintained in the tank.
Okay, आप कह रहे हो कि ये बैरल पड़ा है, यहाँ पे टैंक है, एंड यहाँ पे मैंने पाइप लगा दिया, एंड पेंट यहाँ से जाएगा इधर. तो इसका मतलब यहाँ पे अगर पेंट मैंने डाला और तो वो पेंट जाता रहेगा ना. यहाँ पे अगर पेंट का लेवल ज्यादा है तो यहाँ पे भी ज्यादा हो जाएगा.
Yes.
So the problem just shifts in this scenario to the barrel. We need to move the paint in the barrel, then it's the same thing.
Okay. You want to move the paint in the barrel then?
No, sir. I was saying that in this example, in this previous example, as we like do something that he said, we need to move the paint in the barrel.
Yes.
Yeah,
You're right. You're
the
right.
problem just shifts.
हाँ.
Yeah, it's not.
So that doesn't solve the problem.
Yeah.
But you can still solve the problem. उसी idea को थोड़ा सा extend करो. Think of a pipe connecting the barrel and the.
जिस बैरल में पेंट है उसी बैरल को मतलब एयर के थ्रू भी मतलब जो टैंक में जो एयर है उसके थ्रू कनेक्ट कर पाए, ताकि जैसे ही अगर मतलब टैंक हमारा फुल होता है तो वो एयर बाहर निकलेगी और वो सिंपली मतलब बैरल में जो एक ऊपर से कुछ एक वो फ्लैप टाइप का होगा जो कि बंद हो जाएगा जैसे ही मतलब एयर अगर इसमें ऊपर.
Wow.
We can use hydraulic pressure to control.
Look at this. I'm so happy. You guys have arrived at the answer there. See, this is the answer. As soon as what happens, the level of the paint goes low, lower than this level, what happens? The pipe can now suck in air. The air will go up and the paint would move into the tank. The pressure, the hydraulic pressure that the paint would exert onto the air over here, you know, this height, the depth of this pipe has to be tuned so that the weight of this paint, the weight of the paint above this height matches the maximum pressure that the air over there will exert. Are you able to see this? Do you realize that you use this kind of an arrangement in water dispensers day in and day out? वहाँ पे you have this huge tank, 20-liter tank, 20-liter bottle that you upturn and put on the water dispenser.
Yes.
Yes, sir.
The same principle is being applied here. And now the system, can the system fail? Like there is no pump. The overall operational cost of the system has also kind of vanished. The paint moves itself. You see? And it is such a simple solution that radical trimming brought us to. So again, the problem, the purpose of radical trimming was not to come up with a solution. It was to provide a problem, a new problem, how to make the paint move itself. See, what was the first problem? How to prevent the spillage of the paint. You've now changed it to how to make the paint move itself so that the spillage doesn't happen. And you could arrive at a simple solution, which was based on, say, gravity, hydraulic pressure, and everything. Okay. So trimming, as we say, is driven by a set of hierarchical rules on how to redistribute useful functions of trimmed components. Maximum improvement of a system can be achieved when a function is performed without any surplus components. When you have, so like in this engineering system, there is no extra component, just the pipe and the barrel. That's it. No pump, no motor, no switch, no lever, everything has been removed. The beautiful thing is it brings to the fore new and more effective problem statements, taking us towards more impactful solutions. Again, I reiterate, the goal of trimming is to formulate key problems based on eliminating components and redistributing their functions. Sorry, this is functions. Okay. So we just saw that this is a very unique technique. It reveals a set of problems which we do not otherwise see. It reduces the costs and improves overall functionality of the system. Overall value of each component is enhanced. And how much trimming you want to do depends on what kind of changes you are open to. And the trimming exercise will give you multiple options on, okay, I can trim this. For example, for the toothbrush, we said we could trim the handle, we could trim the head, or we could trim the bristles. So there is a huge range of new problem statements that would appear depending on what component I decide to trim. So we'll close it with some key terms about trimming. Trimming model is the model of an improved engineering system developed through the trimming. Trimming problem is a problem that must be solved to realize the trimming model. Trimming rules is which component, how to eliminate a component by either eliminating the useful function, the object of the useful function, or redistributing the useful functions to some other system components. Redistributing the function means that some other component in the system or the super system will take up that function. Similar function means that functions with similar objects and or actions. That something is holding and moving something else. We said handle is also holding and moving, though it is doing that to the head. It is a similar function that is being performed on a different object. Okay. So with that, we close the class here today. I would want that आप अपनी problems के ऊपर trimming experiment करके देखें and let us see what your findings are. You could probably find, hit a gold mine right there at this stage itself. Okay. Then all that we need to do is implement your solution. But it may not happen. You will just get a new set of problems and then we will work on use other tools to find solutions to those problems. Okay. Any questions? Perfect. Thank you, guys. I will come back to you with if I'm able to identify separate office hours for this week, or if I change my office hours to later part of the week or Saturday, something like that. I will come back to you on that and then see you there. Okay. And I will also release a review quiz for you to refresh these concepts and establish them for yourself. Please attempt that. Okay. All the best. See you.
Thank you, sir.
Yeah. Bye-bye.
Bye-bye.